deserialization. So we essentially, we take the JSON package and we kind of split it up into parts, and we expose also the underlying monad to make it asynchronous and use JSON essentially. And then, well, there's some magic about calling JavaScript callback from Haskell, asynchronous callback. So this was all synchronous that I showed you, the implementation, so how to make it asynchronous. Concurrency is a topic by itself because Haste gives you some concurrency, but this concurrency does not interleave with native JavaScript code. So essentially, either you write everything in Haste in Haskell and you get nice concurrency, well, or you block your UI thread, and getting this right needs a little bit of work, and Haste does not help you so much with it, at least the standard libraries. Well, there's the integration with the Haste FFI parser because you somehow, if you import recursive libraries, and these libraries all have require this. Well, the first thing is you want to have this run kind of automatically. So we integrate. We have a setup.hs script that is in the contrib subdirectory that integrates it, and also with the libraries you want to somehow keep track of the at link time what native JavaScript libraries you have to link in. Haste does not have it, so we have some hacks in a setup.hs file. It's somewhat hacky, but I would say if someone really wants to use Haste in industrial context, this is something that is missing from Haste. So, because you cannot remember for all hackage essentially what libraries you have to explicitly put on the command line. So this is something, if someone wants to really use it, it's something one should work on. And we have the setup.hs script that has some initial code for it, but it's kind of hacky. Well, yeah, quick check testing is topic for it for itself. You can run quick check in the browser, so we do WebSockets essentially to generate instances on the server and send them back to the browser. And well, exception handling is something that one would have to look closer if you want to really use it. Yeah. So yeah, that's it. Cool. Questions? Sorry?
How do you define performance of compiled code?
Yeah, this is something I haven't talked about. One important thing is, well, performance, for example, we made the mistake on having using just the URI instance from the network library, which worked fine. It even compiled, even the parser, but then Firefox told us that there was too much recursion going on. So it seems that JavaScript is not good on tail recursion optimization. And sorry?
It doesn't do any.
Yeah, so although the code that Haste generates looks like it should be possible to do, so what you do is essentially you use the native browser support for it, and you use FFI. That's the main thing. So everything that is slow, use FFI. Although performance is not too bad. Cryptography is really expensive. We implement elliptic curve cryptography completely in. Well, of course, no. Well, we have a version. Actually, in production, we use part of it. We use what SJCL has, but some of the more expensive algorithms we actually implement in Haste, and they run quite good. So. But in order, well, it's still slow. Or for example, here we use PBKDF2, which is, by the way, made to be slow. The problem is, I think last time I measured, there was a factor of 100 between the C implementations that I had from OpenSSL and the one in the browser. The problem is a hacker won't use our, an attacker wouldn't run it in the browser. He will use specialized hardware. So this means we have to make it here really so slow that it's still slow enough on a specialized hardware. Their web workers are one solution if you if you can make this restrictions that your browsers that you have to support have web workers. The other thing that you have to do, at least make it all asynchronous. And then you have to do some extra work, because either you put your whole Haskell code into the I/O monad and program everything in continuation passing style, which really means refactoring all your code and getting codes that, well, some people find it nice. I personally prefer to not write everything in CPS style, only returning unit. But to work around these issues, you have to do some extra work. But you have to do. Otherwise, it's not practical.
Did you run into any interesting memory leaks along the way?
Memory leaks? Not sure. The browser never I don't know how to profile a browser with regard to memory. No, nothing I was aware of.
It's really easy to get memory leaks with JavaScript.
Yeah, but we never run into some issues there. So no, regarding performance, we are surprised actually. It was a prototype in the beginning, and it simply worked better than our crappy JavaScript implementation. So, which simply is because, well, it was done by, we are Haskell programmers, and our JavaScript implementation was simply not good enough, and this stuff, and it's much more maintainable. And particularly in cryptography, types are really cool, because cryptography is all about bytes, and we have these blobs that are just look random, so yeah. So it paid off, and it was efficient enough, so we were surprised. Oh, by the way, the whole thing, our whole production system that has kind of a lot of EC, elliptic curve cryptography in there, and the ESIN stuff and all this, without just using a standard kind of not very special minimizer, we get with a runtime 400K JavaScript, which is, I think, acceptable.
Does it work well on the mobile devices?
I don't have a mobile device, so I don't know, but I think colleagues told me that they run it on a mobile device, but I never did it.
Cool.
Okay, thank you.
Thank you.
Excuse me, what's your computer back there? How's it going? Do you use Haskell at all, or just? Yeah, I've been experimenting with it, but it's good enough not to actually use. I was trying to write a kind of a universal. Universal text handler. Oh, okay. So you pass files in it, and you try to pass in functions as well as parameters. Would be the idea. Because it turns out that just straight coding with the IO monad is not modular.